Okay, I mentioned earlier that when a function isn't one-to-one, we can actually just use part of the domain, only look at the function for that part, and then find an inverse for that part of the function. And that's called restricting the domain, okay? So what we're gonna do is we're gonna look at a function that's not one-to-one. Here we're gonna look at f of x equals x squared minus 9. And that's the transformation of x squared down 9. That should be going through 3. Okay, now this graph obviously doesn't pass the horizontal line test, but if we only look at half of it, if we only look at the values where x is greater than or equal to 0, so that would be the right-hand side here, this part of the graph, that part of the graph is one-to-one, okay? We're completely ignoring the part that I haven't highlighted. Then we can find an inverse for that part of the graph. So we're saying for this function that our new domain, so if f of x is x squared minus 9, and we're only looking at the values where x is greater than or equal to 0, our domain would be from 0 to infinity. And our range, well, the lowest we get is -9, and we go up to infinity. Okay, now the steps for finding the inverse will be very similar. We're going to first put in y for f of x. Okay, now we're going to swap the x and the y, so we'd have x equals y squared minus 9, and we want to solve for y, so we'll add 9 to both sides. And here's where we're going to have to be careful. So to get y by itself, we want to take the square root of both sides. Now normally when you take the square root, we're going to get y equals plus or minus the square root of x plus 9. But we only want one of these. We only want either plus or minus. So real quick, let's look at our function f of x and just talk about a few points. Well, we have 0, -9. We have 3, 0 is another one. Okay, which means when we switch it, we know that f inverse should -9 should give out 0, and 0 should give out 3. Well, if we plug in 0 for x, we want it to be this positive square root of 9, positive 3. So we're only going to take the positive ones, not the negative. So our f inverse of x here will be the positive square root of x plus 9. If we had restricted our domain to be x less than or equal to 0, then we would have chosen to take the negative square root. So here's our function. Now, if we look at f of x equals the square root of x plus 9, well, that graph, we can graph it. We know it goes, -9 is the smallest we can go because remember to find the domain of radical functions, you set the radicand must be greater than or equal to 0, so we say x must be greater than or equal to -9. At 0, we're going to get out 3. So it's going to look like this. And we'll see that that's the reflection of this part over the line y equals x, like we've talked about. Okay, now let's look about the domain and range of our green line. Okay, the domain is from -9 to infinity, right? We can't go smaller than -9. And the range, the smallest we get is 0, and it goes up to infinity. And you'll see again that here, for a function and its inverse, the domain switches and the range switches.